Find the set of values of k for which the equation has no real values, has no real roots. The equation is k plus 2 squared, k plus 2 x squared plus 2kx plus k plus 1 is equal to 0. Find the set of values of k for which this equation has no real roots. So what makes an equation to have no real roots or to have real roots is the nature of the discriminant. And the discriminant is b squared minus 4ac. If the discriminant is negative, remember where the discriminant is coming from the quadratic equation, plus or minus the root of b squared minus 4ac over 2a. Now we are saying if the inside of the root, which is the discriminant, is less than 0, we always fail to come out with the roots, and we say they are complex, meaning that they're not two roots. So this question is asking us to get the values of k for which such a situation will happen, where the discriminant will be negative. So you get your discriminant from here. This is a, this is b, and this is c. So b squared is going to be 2k squared minus 4. A is k plus 2, and c is k plus 1. So we want this guy to be less than 0. This implies that 4k squared minus 4, as we expand inside there, we'll have k squared plus k plus 2k plus 2 is less than 0. We expand further, 4k squared minus 4k squared minus, of course, there that is 3k inside, so 3k times negative 4, we'll get negative 12k minus 8 is less than 0. So our eyes are seeing that this one will be taken away by the other, so that we remain with negative 12k less than negative 8. So it will be positive because that's crossed the inequality. Then you divide by negative 12. We divide by negative 12. The impact of this division is seen on the inequality as it changes the direction. And if you use 4, 4 would go in 8 twice and in 12 3 times. That becomes our solution. If you want, you can say the solution set for values of that guy starting from negative 2 over 3 all the way up to infinity. Unless there are questions, otherwise we may move.
Sir, I didn't get it on 4k squared minus 4 in brackets k squared.
Here you start by expanding this one multiplied by this one. It will give us everything in the brackets. Then there's a 4 outside which is being multiplied by the brackets. So you expand throughout.
Oh, okay, thank you.
Okay. Question 6. This was done in intro sheet 3. And that is intro sheet 3, if not 4. It was the exact question which came on T, looking for This guy has no real values of t for which it does real roots. We go to question 7. Find the set of values of k for which 3x squared minus 12x plus k is greater than 0 for all real values of x. Find the set of values for which this guy is greater than 0 for all values of all real values of x. So how do you do that? First, you get the nature of a discriminant. For this guy to be greater or equal to 0 for all real values of x, what do we require? Since a is positive, we know that if the discriminant comes out to be negative, we'll be so sure that this graph is going to lie up, and it will keep going up. And so for any value of x, we'll be getting the positive value of the whole thing. So say our b is negative 12 half squared minus 4 3 k less than 0. That is 144 minus 12 k less than 0, negative 12k less than negative 144, break by negative 12, break by negative 12, so k is greater than 12. So what this means now is that for any value, for example, you try 3x squared minus 12x plus 14 is, for this value, if we have such a thing, and then you get, let's say, the value of x to be 1, you have 3 minus 12 plus 14, which is bigger than 0. You get the value of x to be 0. You have 14, which is bigger than 0. The value of x to be negative. You have 3 plus 12 plus 14, which is bigger than 0. If you remember, in what was question 3, C and D, where we are dealing with the square root of some quadratic equation of this nature. We said for as long as the value of a is positive, we will require that if the discriminant is less than 0 and is positive, then we'll be sure that the domain there will be all real, because the function will always lie on top of the x-axis, so for any value of x. And so that's how we determine the values of k. Question 8. In the vicinity of a bonfire, the temperature T in degrees Celsius at a distance of X meters from the center of the fire was given by T is equal to 600,000 over X squared plus 300. At what range of distances from the fire center was the temperature less than 500 degrees Celsius? At what range of distances was T less than 500 degrees Celsius? Remember, T is the temperature here. So when they say at what range of distances, X has been given as a distance because it's measured in meters. So when they say at what range of distances would T be less than 500, you know what T is? T is 600,000 over X squared plus 300. This must be less than 500. And then solve for values of X. Now, you know, in inequalities, you don't cross multiply. What do? You bring the other guy this side. But, so in a normal case, we don't cross multiply. That is in a normal case. Why don't you cross multiply? Because the value of X is not known, whether it is positive or negative. So we avoid not knowing what to do to the inequality. But this time around, whenever you are told it's X squared, you know the value is positive. Then you're adding another positive number. So it becomes so clear that cross multiplication here can be done without any restrictions. So we'll have 500 multiplied by X squared plus 300. Without changing the inequality, because the number that we are multiplying with is positive. That's why there's less impact there and it's negligible. So we'll have 600,000 less than 500X squared plus, we expect to have 4 zeros there as we multiply 3 by 5 to give us 15 and the other 3 zeros. So we'll get 150,000. So we subtract, since there's no X attached there, we subtract this number. So now what we have is, so we can work this number in reverse. This 0 is less than 500 X squared minus, okay, to avoid losing N1, we do this like that. So we get 0 is less than 500 X squared minus 600 minus 150. This is going to be 450. If I'm not mistaken. Yeah, 450,000. So what does this imply? If we factor out the 500, we factor out 500, we'll remain with X squared minus, you break the 2 zeros there, you will have 4,500 divided by 5, which is 900. So you get 900 here. This guy is greater than 0. So that when you divide the 500, you have X squared minus 900 greater than 0. This is a difference of 2 squares. It looks like, so it will be X minus 30 and X plus 30 greater than 0. So we have critical numbers, X is equal to 30 and X is equal to negative 30. And so we can form a testing table or a testing number line where we have -30, we have +30. We can choose 0 in between. Choose 40 this side and choose -40 the other side. So easy to test. When x is -40, we have -40 minus 30 multiplied by -40 plus 30. Automatically, this number becomes positive altogether. Because we have negative times negative, so we get positive. If you place 0 there, you have 0 minus 30. You also have 0 plus 30. This number is negative. If you place 40, you have 40 minus 30. You also have 40 plus 30. This number is positive. Our interest is having our inequality bigger than 0 because 0 is less than. So it's bigger than, so we get the positive part and form the solution set. So we'll say x ranges from -infinity all the way up to -30, not including -30, union starting from 30 going to +infinity, unless there are questions.
Sir.
Hello.
Sir. Yes,
Yes.
sir. What about if we've not cross and multiply? We use the same method of testing just from there, 600,000 and over x squared. And is it going to give us the same thing?
What numbers are going to be testing?
We draw a testing table where you cross and multiply it there.
You mean from this step here?
Yes.
Then we draw a table.
Yeah, because like in the former, I've understood to say since we've got positive, we can cross and multiply. But in any cases whereby maybe we want to use that method of the normal method which we use,
where you take 500 this side.
Yeah.
And then start solving.
Yeah, and then
there'll be nothing wrong.
Yeah.
You can do the calculation like that because the denominator won't give you any critical values, since when you try to solve for x, it will be giving you complex values.
Yeah, that is what I found. Now I was thinking maybe meaning it is not applicable on this question.
It's applicable, except that when you have no critical values from either the denominator or the numerator, you forget about that section and do the section which has critical values.
Oh, okay, sir, I understood.
All right.
Sir, I have a question.
Ask.
Hello, sir.
Yeah, you can ask.
Yeah. What if when I find those critical values, then I did come up with that number line, then I just write the solution set. Is it wrong?
You just do what?
Just writing the solution set without writing that table.
Without having the number line.
Yes.
Or table. No, look,
Yeah.
the way your questions will be phrased will be, show your solution. So how do you get to know that it's this region or the other region?
Oh, okay.
Working must be shown, 1. 2, you need to help yourself know which intervals are necessary.
Okay, thank you, sir.
Okay. So you move.
17, yeah, 5.
So you move to question That was question 8. So we are now on question 9. The gas mileage G measured in kilometer per gallon for a particular vehicle driven at V kilometers per hour is given by the equation G. G is equal to 10 plus 0.9 V minus 0.01 V squared. As long as V is between 10 kilometers per hour, as long as V is between 10 and 75. So this G is defined as 10 plus 0.9 V minus 0.01 V squared for values of V ranging from 10 to 75 only. For what range of speeds is a vehicle's mileage 30 kilometers per gallon or better? For what range of speeds is G greater or equal to 30? So the only work you have in an exam is understanding what they mean by the statements for you to form the mathematical equations. Once you have the mathematical equations, then you are able to start solving now. So from all these explanations here, the question is asking us to get the range of values where G is greater or equal to 30. But you've been given the values of G. You've been given G as an equation, 0.9 V minus 0.01 V squared. Now this should be greater or equal to 30.
So I can't get you.
So I can't get you.
So I can't get you.
Sir, we are not getting you.
Mzapeza
we
abasiriza
can't get you.
nosiza.
Yes, sir. Like I don't know, maybe it's network, which is preparing. We can't get you there.
Yeah, can't get you.
Wanika maybe
The sounds on mute.
Wait, he's taking tea.